You're supposed to remember that these are one and the same. So 5.34 centimeters cubed is the same as milliliters. They are one and the same. All right. What do we do for grams to moles? You better not cry. Make the T chart.
5.37.
What goes on the bottom? On the top. What goes beside moles? What do we know about grams? Oh.
32.
Why?
Because O2.
Correct. It's one of the 7 diatomics. 16 times 2 is 32. Oxygen is diatomic. It's one of your 7 diatomic molecules. All right. One of your 7 diatomic molecules. So 57.3 divided by 32. Keep telling y'all this stuff's not going away. 1.79 moles. All right. How do we change Celsius to kelvins?
273.
K equals C plus 273. Where do you find that whole thing at if you forget it? On your reference table. You can look it up. So K equals 34 plus 273. I think it's 307. Thank you. I was getting 301 and I was like, that is so wrong. All right. And we're finding Kelvin, so we write K at the end. Questions?
Question.
Mm-hmm.
That's a 1.79 moles for 3, right?
Yes. That's correct.
I remember the first one. I know. I just couldn't remember the formula, but look at my records. That's the problem. Like, let me get a calculator.
I didn't think about it until
He's like,
And you will need calculators today. You have to figure that out.
well,
I just figured it out.
give me one.
Angel, you say you want Yeah, you do.
I was not everything. Look,
Now, they are for a limited time, and I will tell you which days we're going to do them in a moment. Going out. Not today. No, yeah. All right. Now, we are going to do test corrections. I told you I would yesterday, so you have one test this quarter that has them. All right, so we're going to do them next Tuesday and Wednesday. And then I'll see what we got the following week. That way my athletes have something. Hopefully you don't have a game on every day I have available.
we have 3 games next week.
aren't you
I cannot fix your athletic schedule. All right. Next week is the 3rd. I cannot do Thursday because I have a data dive thing. And then the following week, that puts us on the 13th, 14th, 15th. Let's see what I have that week.
So we can do every day but Thursday next week.
Well, I have Tuesday and Wednesday. Monday I have a staff meeting. So I can't do anything about Monday or Thursday.
I can see what you're
I can't fix that. All right, the following week I can also do Tuesday and Wednesday.
Are those just the next 2 weeks?
Yeah, those are the next 2 weeks.
So
that's 4 days. Now, do you have basketball games on all 4 of those days? 3 out of the 4.
wow.
However, if they're home games.
If they're home games, that means you don't have a game until when?
So we don't have to do that.
Okay, well, if they're home games, I mean,
We have one home game, and it's what is that?
well, maybe you can come for a little while before you have to go, eat warm-ups. I mean, you don't have to do them all at once. You can do a little bit on one day and then come a different day. Okay? Now, when you come, I do go ahead and mark what you've done and go ahead and put those in my grade book so that I don't have to do them all at one time. So, but if I go ahead and update your grade in the grade book, let's say that first Tuesday, and you come the last Wednesday, I will update it again on that last Wednesday. All right, so don't feel like that you can't come back if you've got a game and you miss the next 2 opportunities. All right, so those of you who work, see if you can rearrange your schedule for the second week. If you're lolly and you don't have anything next week, maybe you can rearrange for the following. All right, but those 4 days are when we'll do test corrections on this test. A lot like what you were doing in the Bowers class. You already done one way back at the beginning of the semester. We did it on the first test.
I didn't do your.
Oh, then y'all just didn't come, but we did them on the first test.
So we get half the points back.
Yes, we did. I didn't have a lot of takers on the first test, but we did it on the first test. All right, you essentially have to tell me or show me how to get the right answer.
Okay.
Okay, so if you got, let's say, question, the people who were not here to take the test, so Lolly, go out in the hall, Karina out in the hall, I think that was it. Everybody else can see. Well, I can use a real test question. Not that I probably remember, but that's beside the point. I'm just going to borrow Angel's paper here and use number 3. All right, so question number 3 says, which of the following has the largest radius? Okay, and you've got answer choices of A, B, C, D, E. All right, answer A is what? Phosphorus. So you've got phosphorus. B is sodium. C is neon. No, argon. I'm off a row. D is magnesium. And E is chlorine. All right, those are our answer choices for question number 3. So it says, which of the following has the largest radius? Well, you know radius decreases and increases, right? So for Y, you could simply have said that I know this is all in the same period. So sodium is here, magnesium is here, phosphorus is here, chlorine is here, and argon is here. So I know as they go across what's going to happen to them. They're going to decrease, right? And the question says which has the largest radius. So this one has to be the largest. Something that simple in the box for Y will work for me. Okay? Because you're explaining how you knew it was the largest. I don't have to have anything in great detail. But you can't simply write down the answer that's on the paper. Because I gave you the answer on the sheet that I stapled to the back. All right, you could correct the free response also, but you have to show me how to work it correctly. You can't just draw the Lewis structure. You have to draw the number of electrons and explain. If it's the geometry, you're going to have to tell me how many atoms, how many lone pairs, and at least explain how you knew the geometry. Or how you knew it was nonpolar or polar. Yes, ma'am.
Okay. So for like, I didn't listen. So if we don't know the reason why it's the answer.
Yes.
Yay.
That's what that came for. You can use me, you can use a classmate, you can use your names. And you're all the above. Huh? The point behind test corrections is for you to learn what you didn't learn the first time. There'd be no point in test corrections if I wasn't going to help you. I'm kidding. Well, it's for you to learn what you don't know the second time around. So yes, I will help you.
Okay, that makes.
Okay? Anything you just dying to know and you gotta know at this moment in time?
Yes.
No.
Wait.
Otherwise, I'd really like to move on with the gas laws, because we are 3 days behind. We're not gonna get 3 days caught up, people. Unless we suddenly get 3 days put back in our schedule, we are not going to get our 3 days.
Let's start right now.
I need 95 minutes times 3 days. There's no catching up.
Oh, how did we get them?
Because we lost 3 full calendar days that they didn't give me back.
So it's not our fault.
It's not your fault, it's the hurricane's
And I
fault.
feel better about it.
Hey, we need another one.
A whole question number, because I missed it.
Another one did show up now.
Plus one.
I mean,
I've heard of
They're
things.
just got this
To be fair, Texas did say, let me have every kind of weather condition and season in my state.
I got 2 things right on.
What if that?
Well, I don't know how to do those.
That'd be fabulous.
That's what I was trying to do.
Oh, that's in the back, yeah.
Yeah, you cannot keep them.
Why not?
I said so.
I thought study that.
Let's not.
And you guys give me
What'd you do with it?
You had it.
This walking out question.
Oh my God.
Yes.
We still have my little sister too. My mom makes me move. We need to come up with 2 days. We need to be creative.
And on your way out, tell them to come in.
Oh, sorry if you didn't know whether or not to be.
What I love about you, your arms are so long, I don't have to fall over and stuff to get stuff.
Oh.
Alright. If you will, find your notes. Yes. Now, today is probably the most note-intensive day of all of them, simply because we don't know anything yet. And we got to do the theory stuff. After today, it will be much more math-oriented. All right, so yesterday we talked a little, not yesterday, the day before. On Wednesday we talked a little bit about kinetic molecular theory. And we said that all particles in matter are in motion, right? Whether we're talking about a solid, we're talking about a liquid, we're talking about a gas, the particles and all kinds of matter are in motion. Now, we said that they can vibrate, they can rotate, and they can translate. Solids can only do what? Solids can only vibrate. Liquids and gases can vibrate, translate, or rotate. Motion doesn't stop until we reach what temperature? Absolute zero. And even though it was pretty chilly earlier in the week, we were not even close to absolute zero. Now, from there, we said we were going to study ideal gases, right? Now, an ideal gas has to obey all 5 assumptions of kinetic molecular theory. And we started talking about the 5 assumptions on Wednesday, and we had gotten through 2 of them, and we'd started to write down the 3rd one, and we ran out of time. So the first 2 assumptions were, number 1, all gases consist of a very large number of particles. So the example I gave for that was we were going to use moles. So in our word problems, if it said we had 1 mole, how many particles are in 1 mole? 6.022 times 10 to the 23rd. That's a huge number of particles. So that's not hard for us to imitate in our word problems. Now, gases are going to move in straight lines and be in constant motion. Now, number 3 is where we were, and I think it was Diamond who said, I can't get that. So I said I'd come back to it. So, all collisions are elastic. Now, elastic is a new vocabulary word for us. Elastic means that there's no net loss of kinetic energy. Okay? Now, truthfully, when particles hit each other, does all of the energy get transferred from one molecule to another? No. Some can be lost as heat. Some molecules are going to keep some of the energy and transfer some of the rest of it. But according to an elastic collision, all of the energy is going to be transferred. So we're going to make that assumption. Now, number 4. There are going to be no attractive or repulsive forces between the molecules. Now, in gases, the gases attract or repel each other. Yes, they do. Some gases attract, some gases repel each other. Now, to make our life easier so we can do our math calculations, we're going to assume they don't. So how can we assume that they don't attract and they don't repel? Thinking back to what we did right before the test. What were the weakest type of attractive forces we talked about? The day before the test. Those were bonds. Attractive forces. The day before the test. All right. They were with covalent molecules. The weakest type of attractive forces. London dispersion forces. Now, what kind of molecules had to go with that, Sailor? Who had to be with London dispersion? Nonpolar. So what did I put in parentheses up there? Nonpolar. Okay? So nonpolar molecules are what we're going to use when we calculate because they have the weakest attractive forces. Okay? Everybody who's nonpolar had London dispersion forces. Okay? Everybody who is nonpolar has a London dispersion force. They're the weakest of all of the forces, and that's why we're going to use nonpolar molecules. Because truthfully, gas molecules attract one another, and we can't avoid that. Now, the average kinetic energy of the particles depends on temperature. The faster a molecule moves, the higher its temperature. We all know this. We've known this probably since middle school. Higher temperature equals more motion. So if we raise the temperature on our gas is going to do what? Is it going to move faster or is it going to move slower? If we raise the temperature on our gas, will our gas go faster or will it go slower? It will go faster. Okay? And that's true for anything, not just gases. If you raise the temperature on the gas, it will have more motion. All right, we caught up? Yes? All right. So, what conditions will give us an ideal gas? What things are we going to do in our word problems so that we can get those things we just wrote down? Okay? All of our word problems are going to have these things. Number 1, we're going to use nonpolar molecules. So we're going to use things like carbon dioxide. CO2, every time we drew it, was nonpolar. We're going to use a lot of diatomics. The diatomic or nonpolar. So, you know how earlier when we calculated in the opening and I used oxygen and y'all all yelled out the mass was 16, and I stood there and said, nope, because you forgot O2's mass was what? Those are going to come back and bite you. So what are my 7 diatomics? Hydrogen, nitrogen. That's the Hector now owns 5 clear brown iguanas. Okay? Those are the things you have to remember because they're going to come back and bite you. Okay? Now, what else are we going to have? We want the molecules to move far apart and not attract. So do we want the temperature to be high or do we want the temperature to be low if we want them to move far apart and not attract? Yep, so we're going to have high temperature. Okay? You're not going to see a lot of negative numbers in our math problems. We want high temperatures. And we don't want them to attract, so is the pressure going to be high or is it going to be low? It's going to be low pressure, so the pressure is going to be low so they're not squeezing up on each other. Okay? That's how we're going to keep those gas molecules from attracting each other. High temperature and low pressure. Now, the other thing I put up here is what is a real gas. All right? A real gas is a gas that really exists. Okay? It's a gas that does not obey those 5 assumptions. And they exist in nature. You can calculate with a real gas. We just don't do that in a first-year class. If there's anybody in here who intends to pursue a science degree at college, you will do that in upper-level chemistry classes. I don't expect there's many of you in here who will ever do that in your lifetime. But if you ever do pursue an upper-level science degree, you will eventually have to do that. If your desire in an upper college career is not a science field, you will never do that. Okay? And the question I asked you a second ago about some ideal gases, I just gave you a couple examples of our ideal gases. Now, notice I left bromine and iodine off. Why did I leave them off? Okay, why? Which one's a liquid? And what is iodine?
What?
Something's in purple. It's not necessarily wrong, but it's a what?
I don't know.
I failed y'all.
Is it okay? Are we supposed to know this? I remember like we
What? It's a solid. Bromine is a liquid and iodine is a solid. We learned the states. Now, they can be turned into gases, and they can exist as a gas. But in their normal state at atmospheric pressure and room temperature, they exist as a liquid for bromine and a solid for iodine.
I said, I said purple.
You said it's an element. I wasn't kidding.
Oh, I'm going back. Excuse me. I'm a little testy today. Y'all know what you think. I'm in a bad mood. I was just testing. Hello, yeah? Did you come on a bus? Oh, okay.
Now I see.
Say what?
If they really think what bus were you thinking? Just got here. She said that.
What about it?
There's a
I didn't know if you put it in.
Chemical bonding.
Next you know, bus actually just
Not a clue.
this
We're
is
back
one
to
of
the-
I really might.
I don't know how to feel.
Alright, so all gases have 5 properties. One is the ability to expand and fill their containers. Okay? Now, sometimes students will tell me that liquids have the ability to expand. Back in the days, Angel can remember these, when I was hooked on Pepsi. Oh yeah, I was never without a Pepsi last year. I still miss those days. What? But anyways, I used to hold up my Pepsi bottle and ask if Pepsis would regenerate themselves.
Yes.
Like refill automatically. That would be great. It would have been so great back when I actually could drink Pepsi. But I would drink either or. It didn't matter to me. Pepsi was my choice, but I certainly would not turn my nose up to the Coke. But I've given them up.
Don't say your nose,
I
man.
love that
Don't
choice
say your
of
nose.
I did not mean in that sense, Wally. I meant Coca-Cola. As in the soft drink. That's true. I wasn't planning to produce it or snort it. Just drink some Coca-Cola. You know, since I haven't had any since August the 1st, I would really like a Coca-Cola.
Well, you got your Pepsi Cola.
My daughter told me today this is the most god-awful thing she'd ever seen until we made a change this morning. I was like, I thought I did pretty good. It's like, it's not orange. I said, well, it's going to have to work this morning because I'm not changing. I didn't build in the time. Now, I didn't think it was terrible. Do you think it was bad?
It's a little too much blue.
A little too much blue?
Maybe that's a white shirt.
Okay, I'll work on it for next week.
Thank you.
I'll tell her that y'all agree. She will feel
No,
validated.
we did it not like she did.
It could be like brown and navy or black and navy.
That's 2 days in a row she criticized my outfit. So I told her, I'm not fashion icon. It's okay.
My stepdad trying to walk out the house wearing red pants and a pink shirt. And I told my mom I was not going to be seen out in public because she didn't tell him to change.
That would be pretty bad.
I did stuff like that on purpose.
But my point is, drink containers do not regenerate. They do not refill themselves. My choice was always Pepsi. Yours might be tea. It might be a Gatorade. Whatever it is, it does not self-generate. Oh, so when you're thinking about do liquids in our next unit, do liquids expand? Think about whether those containers will automatically refill. No. So those of you who come in with breakfast in the morning, do your drink containers refill by second period? You wish. So the answer is no, liquids do not expand. Only gases fill their containers. Now, liquids are also compressible. All right? They squish. You are able to move them into a smaller space. The reason is, when you were taught about these years ago, your teacher probably drew some picture, and they drew spaces between all these molecules. There is a lot of space between gas molecules. Because there is all of this space, those molecules can be pushed together and shoved into a smaller space. First period.
It never stops. She repeats.
Every 5 minutes.
Ask you something.
Number 3. Gases have a low density. All right? Now, why do gases have a low density? Why are gases such a low density?
I was gonna say they float.
Well, they float is an interesting theory.
Well, they theory dense and floats.
Well, think about CO2. All right? If we blow up balloons for a birthday party, and we use the gas, that we exhale, where do the balloons go?
To the floor.
The floor. So do they float?
No.
No, so we can't just say they float. Okay. I wrote the formula for density on the board. Okay? So think math class. All right? The mass is a small number, and the volume is a what? is a big number. So what happens in math class if you divide a small number by a big number? That's right. You get a very small number. You get a very small number when you divide. That's why gases have such a small density. All right? Because the volume is huge and the mass is very small. And you guys know from math class, when you divide a small number by a large number, you get a very small number. You don't know nothing. Yes, you do. All right, fluidity. Gases are fluids. Their molecules are not locked into position. They have the ability to flow and move around. So you guys are able to easily swing around in the air and move. The gas molecules are not locked into place. In a solid, and we'll talk about this again when we do solids and liquids, solid molecules are fixed. Their molecules don't move. If I tried to walk through this door, what would happen? I'd probably hurt myself. I can't get through there. Notice I didn't push my wrist against it. Okay? I can't. The solid molecules don't move. Okay? I know, I can't push my wrist, but I might hurt myself. That's what happened when I hit the sidewalk. It didn't give. It's not pretty. You should come to fourth period. Sometimes they have questions at the bottom of the opening. Number 5. Who fell off a sidewalk?
Oh. That's so mean. That's actually kind of funny. I mean, at least did you laugh after it happened? Maybe probably didn't because you broke your hand. But like,
How high up was that sucker?
I would be like, that makes more sense.
How did you fall?
It wasn't a side. I didn't fall off the sidewalk. It was a sloped ramp. I just called it the sidewalk.
They
You
slowed
should
it to
clarify
rest.
that.
I fell
How did you fall? Did you like slide down?
It wasn't a slide.
You said it was a sloped ramp.
It was a ramp for like, first of all, it was an auto parts store. My husband sent me to get a part for his truck. I was not familiar with the auto parts store, so I walked out of the door carrying a box. All right, I cut across to go to my car. So I did not realize that there was a ramp for hand trucks and cars. Fortunately, it just tumbled and rolled across the parking lot. And I did not break the part, it survived. I did not break my phone either, which is another miracle in the story. I just broke it. No.
You want to help you?
Some very nice older gentleman who's coming across the parking lot did help me up, yes. So I cut across to go to the car. I did not realize that there was a sloped, curved out ramp. So when I went across it, I didn't pick my feet up to walk up the ramp. So my
face planted.
No, I didn't face plant, but I went sort of sprawled out and my arm was out in front of me and that's what broke my wrist. So the box tumbled across the parking lot and I went down. And some really nice older gentleman helped me up off the cement and I drove home to Greensboro out by the airport with a broken wrist in my life. I did not go to the emergency room. No, tell doctor story? Yes.
Did they laugh at you?
No, they told us to go to the emergency room. But my deductible to walk into the emergency room is $300 before they touch me to walk into the emergency room. It's only $40 to walk into the doctor's office here.
See, other people like you. So yeah, the doctors don't spend the money.
No, it wasn't about just that. So I spent $40 here where they referred me to the hospital to go have x-rays. So I still went that afternoon. I had the x-rays. I didn't have to pay the $300 initially. Then, once I got there, they sent me home to wait on the outcome. I didn't even make from the hospital to, if y'all know where Tyro Road is, before they called me, sent me back to the emergency room to tell me I might need surgery. So I still got sent to the emergency room, but it didn't cost me $300 to walk in the door initially.
So you said the whole time.
Yeah. Like First Baptist and I have an 8-8 relationship. So I was not getting the $300 to walk in the door.
Has no one ever told you that if you fall, like, don't do that?
I don't remember sticking my arm out. I just remember falling off the sidewalk.
Can you show me how you feel?
No, for fear I'll do it again.
I broke my wrist.
I probably shouldn't take up our porch and shoot either, should
Did you really
Yeah, I did it pretty hard. It was a small porch. I was trying to hand the keys to my daughter. I had a bunch of things in my arm. I stepped back too far and I missed the edge of the porch. I went down, scraped my entire leg up with road rash, and cracked my head on the foundation of the house. I almost wound up in the emergency room that night with a concussion, but I did refuse to go.
That's not good.
Yeah.
I mean, she's here now, so I guess she's okay.
I didn't have no signs or symptoms of a concussion. I did have a little bit.
I know someone that had a hip on like and they were going someone's yard and got stung by one, and like didn't call 911. Like repeatedly called my mom over and over and over again. She didn't have a phone with her, so it's like 30 missed calls, and they were just laying on the side of the road, like almost not able to breathe.
No, I'm not that bad.
That's just like.
If I'd had more than a headache, I would have gone to the emergency room. I only had a headache. That I was bleeding all over the place.
Well, that was like.
We just bandaged that up. All right. All right, diffusion. All right. Diffusion is the spontaneous mixing of two or more things. Now, this can be liquids or gases, and I'll even talk about solids when we get there. Now, notice the word is spontaneous. You cannot stop diffusion, okay? Whether it be perfumes, colognes, some of the guys or girls, if you have friends, I'm just going to assume y'all don't do this. If any of your friends in class pass gas, it doesn't stay with you. It spreads the joy, okay? It can't just hang with you. So be mindful of that. If you feel the urge, ask your teacher to step out in the hallway. Okay?
That's embarrassing though. I'd rather fart in the glove with somebody else.
Okay. Now, we're going to use 4 mathematical quantities of gas laws. You will recognize the first 3 because we reviewed them in the opening. We've done them during the course of the semester: volume, temperature, mass moles. We've done those 3. Number 4 is pressure. We have not studied pressure yet, so we have to do that today. All right. Now, pressure works just like a lot of the other things we've done this semester. So it really should not be that bad because it's very, very similar to converting volumes, which we've done. And I know you've pushed those things out of your files, or we need to dust them off, but it's going to come back pretty easily, I think. They work just like everything else in the T-charts. Now, pressure is force per unit of surface area. Pressure is just force per unit of surface area. Is that your water, or is that left over from yesterday? That's my water. Just checking. All right. So you have to know the relationship between pressure and surface area. And this is, I think, an easy one to remember if we do a nice, easy, short demo with this. So catch up with me and we'll demo this one. All right, we there? All right, stand up beside your desk for a minute. This is easy.
What makes you think I would stand up and fight?
You're getting much better about standing up in the pledge. Next semester, I'm on fair.
Wait.
Do I have to stand?
Only for a minute or so. Not very long.
What if I just take my phone?
Well, why don't you just take the butt off the chair? You got to stay up.
In the fence.
All right. While we're standing here, what makes up our surface area?
Makes up what?
Our surface area.
You talking about us or like?
We're standing. What makes up our surface area?
Our feet.
Our feet touch the what? The
The
floor.
ground.
Okay, so our feet touch the floor, make up our surface area.
But I thought nothing
Okay.
ever touched.
All right, what makes up our pressure? Our weight. Our weight is our pressure. Our feet touching the floor is our surface area. Okay, everybody with me on that? So, some of us have more pressure than others. Right? Clearly we do. I lost 30 pounds this past 4 months. My daughter was pleased with me yesterday. I don't have to go on more blood pressure. That's something after 24 years of my blood pressure yesterday. I didn't even have to blame y'all for your chest raise. So, yeah, I was throwing y'all under the bus yesterday, but my blood pressure was up. So, now, stand on your toes.
Wait, I'm uncoordinated. So I'm
So am I.
That's
Catch
how
me if
I
I'm
walk
falling.
I'm not walking away.
Alright, so, tell me what you did to your surface area. You decreased your surface area.
But I'm kind of.
Alright. So, what's happening to the pressure now? It's the same?
It's increased.
Why do you love that?
Your pressure should increase on the, if you have less surface area, walk around on your toes then and see if it changes.
I can't do that.
Sorry.
This is all I've been trying.
Yeah, when you eventually on your toes. I'm talking about just stay on your toes.
Oh, yeah.
Okay.
It'd be so funny.
Now, you can sit down. So, what did we do to the surface area? We decreased it. And what happened to pressure? So what's that relationship? Inversely proportional. All right. So they're inversely proportional. Is surface area increased, pressure decreased. Now,
I really do have.
this is why young ladies who wear really, really tall heels, and they do it for extended periods of time, wind up with foot trouble. Is there else? Yeah, I've worked with 2 ladies here over time who had to have foot surgery because they wore high heels their whole teaching career.
I can't wear heels like that. Anyway.
Yeah.
I thought nothing ever touched.
Whatever.
Nothing. I was told that so there's like a very thin layer between the 2 things that
There was a time where I actually.
What?
I'm talking about
I just
life.
heard,
Like,
like that, rejecting each other.
I'm assuming Mr. Al told me that.
I suppose that's possible. I have no idea. She's much more well-read than I
What
am.
was going on? Yeah.
You should look it up.
Okay, so.
I'll just tell you all
What's wrong?
In my free time, I choose not to read either intellectually. Okay? Now, there are 5 pressure units that we're going to use. Okay? 5. Because, I don't want to limit myself to 1. So these are the 5 pressure units that we're going to use. Some of you will say ATM and call it atoms. And I will correct you every single time because I'm that nitpicky. All right? ATM is atmospheres. Okay? It's not atoms. ATM is atmospheres. MMHG is millimeters, and HG is mercury. So millimeters of mercury. Torr is named after the Italian scientist who created the barometer, which is how we measure pressure. Pascal is I forget where he's from. Can't remember. He could be, but he did a lot of work with pressure also and gas laws. So he gets a unit named after him. And because that unit is in scientific notation, because it's so small, we use kilopascals because it's a bigger number.
Have you ever seen? Oh my God.
What's wrong?
I'm not. I can't.
What can't you do?
With them,
What's wrong with them?
they.
They're just special.
They've never seen Love and Basketball.
They've never seen what?
Love basketball.
Y'all never seen Love and Basketball?
Oh my God.
Black card revoked.
You don't even have to be. That's a world.
Have you ever seen?
I don't know what y'all
Heard of it,
talking
sorry.
I have not seen a lot of
Like I said,
stuff.
black-
I don't watch much TV series.
Yeah.
It's an amazing movie that makes me cry. It's like Rent.
What's Rent?
You've never seen Rent?
I've never seen it. I've never heard
What
of
is
it.
Rent?
Even I've seen it heard Rent.
I don't know if you know it. Like,
You see Rent?
I love basketball.
Rent made me cry.
I don't even know what that is.
All right,
A musical thing?
those
Now.
are really big numbers.
here are the conversions we're going to use. I have good news and bad news about these.
The bad news is the numbers are too big.
No.
Yeah.
She said he could pressure you.
Now, no.
What the? You seen it?
The first three over there are on your reference table. The last one is not. Now, the state, I'm sure, will not ask you about PA. However, I will. So, on the first quiz we will take next week, you will see PA. You will see PA on the test. So you will need to know PA. You're in an honors class. We've had this conversation.
Is our test going to be after Christmas?
On the gas laws?
Miss
No.
Ball.
You will see two tests before Christmas break.
Right.
One is the gas laws,
2 weeks, 3 weeks.
and you have to have a benchmark the week of Christmas. Now, I don't know if the benchmark will just be a test, or if it will be a benchmark. That hasn't been decided by me yet, but you'll have something.
Can you like actually like be nice and like give us like one of your tests as your?
I haven't decided yet.
That's so nice that she's.
I haven't
she's
decided
not
yet.
giving us a test on Friday.
Miss Wall, have you seen Friday? No, seriously, because the neighbor hasn't seen it and Sailor has.
Is it a movie?
Yeah.
No.
Never, no.
Friday.
I just said a minute ago that I don't watch a lot of movies, so.
No, these were a long time.
So I finally seen Ace Ventura.
Oh, I've never
That is
seen
the dumbest movie on.
What are you?
It is.
But he's.
All right, does everybody have it so we can talk about how to do it?
Wait.
Now, being able to make these conversions works the exact same way as any other conversion we've made using the T-chart. Okay? Now, if you look at the front page of your reference table at the very top, you will find the conversions for the gas laws. If you are one of those people who's like Anthony with these numbers are too big, or I can't learn these numbers, or I don't want to learn those numbers, they're in that top chart where the Avogadro's number is, and then I think it's right below it. It says the gas law constant, and then below that. All right, but all of our gas law numbers are in that top chart. Now, if I give you 625 torr, and I want you to change that to KPA, okay? How would we do it?
You go to that, you would take the toy and turn it into the atmospheres.
Okay, so torr, we'd put torr on the bottom. Owen says change them into ATM. We can certainly do that. So torr to ATM, I don't want ATM, so I need to make my chart longer and then put ATM on the bottom and then go to what on top? KPA. That is certainly one way to do it. All right, so I'm going to put what beside ATM? Well, if I cruise back over here, ATM has what number beside all the ATMs? Ones. So I'm going to put 1 besides the ATM. What number is beside my TOR?
760.
760. So 760 beside the TOR. And what beside the KPA? So 101.325.
So the only number that's not on the sheet is the last one?
Yep. Now, that is not the only way to solve this. Now, we could just as easily have said 625 TOR, put TOR on the bottom, and put what on the top? Yes. We do not have to go through ATM here. Unlike moles, where moles can have different numbers. And yes, we will do stoichiometry where the moles can have different numbers today. Oh, yes. Gotta love it. All right. Not in the next couple days. Don't panic on me. All right. That's the last thing we will do with the gas laws. But moles will have different numbers at some point. Okay. So when you're trying to fill in these numbers, knowing that ATM is always going to be ones, do we need, I thought y'all would quit that. All right. Knowing that ATM can only be a 1 and it's never going to change, do we need to include them in the chart?
No.
No, you can leave it out. Okay. So if you want to draw a shorter chart and leave that out, you can. So ATM is gone. TOR will be what? 760. And KPA will be what? Yep. And that's the shorter version. Okay? You choose the one you like better. It does not matter to me which one you pick. There it is. Okay? Say what?
We're doing 50% digits.
I'll be the first to tell you I'm not grading significant digits. Provided you don't write every number down on that calculator.
Yeah, totally.
Okay? Provided you do not write every number on that calculator. Okay? Now, you should be close. If you're within 1, I'm good. You start writing most of the numbers down on the calculator and I'm going to grade significant digits again. Okay? Everybody hear me say that?
Yes.
Okay. But significant digits are not on the state test. Everybody has them mastered at this point, so I don't feel a need to continue to grade significant digits. Units have not and will never go away. Did everybody hear me say that?
Yeah.
All right. Everybody feel comfortable doing this? Okay. Let's talk about, because I'm going to give you homework with that. I know you didn't just swear.
What? He said she knows you didn't just swear.
Okay.
I didn't finish it. I could have.
Well, thank you. I get enough of that later in the day.
You're welcome.
So leave something in here, and I'm not gonna remember I left it till fourth period.
Say what?
I'm gonna leave something in here, and I won't remember I left it till fourth period. And then I'll check it.
All right. So, I want to do at least 1 or 2 gas laws today, just so you get a feel for what we're going to be doing next week. Now, I'm going to teach the gas laws in 2 separate groups. All right? We're going to divide them up into those with mass and moles and those without mass and moles. Okay? So we're going to start the easy ones first. We're going to do those that have no mass and no moles first. So we're going to do the ones that have no grams and no moles first. So you're not going to have to worry about anything on the periodic table. No moles, so none of the diatomics at all for about the first 3 days. Okay? So these should be the easiest ones to do, and the first quiz grade should be stellar. Everybody said that?
Should.
I'm going to be seriously disappointed if they're not.
I mean, I'll be disappointed too.
Yeah.
All right. So Boyle's law is going to be about volume and pressure at constant temperature. Okay? You gotta be kidding me. Stupid Friday notes. Yes, you may. That is an excellent question. I have no idea.
It's what random stuff.
Wait, Friday knows what?
I just throw them in the trash.
You don't do the thing that you just came here and handed us.
Wait, but what
Yeah,
is it about?
that's like little slips.
They ask you a question and
What
you
would you change?
gotta fill it out.
Yeah, and I just throw them in the trash.
What is your opinion on this? And then. Don't you like let people out? It's supposed to be anonymous, and you like lose.
Oh no, you gotta put your name on.
Yeah, for the teacher. Wait, so do you get in trouble?
Depends on what you write down.
Wait, Sue, that's like.
I guess it's not mom said.
That's my mom.
That sounds like a
That's my
parent.
mom.
That sounds like a parent.
What do you want to eat? I give like a choice.
Oh, I feel nice.
Yeah.
Okay, well then, I guess I'm not hungry anymore.
And then she gets
It was
mad.
like so chilly at me. Like,
Where
where
do you
have
eat?
you
I don't
ever?
care.
Where do you eat?
Yeah, like, I was out there with Josh on the face on shit outside, and I stood up in my head, and it was like,
My mom goes, "Why don't I like cheese now?"
it was very, and I was like, isn't that what I said? Okay, so he, and I was like, sir, and he was like,
I'll eat breakfast.
something, and now he was in there.
Alright.
That's a lot. Oh.
Alright. So your multiple choice questions on the test come from the stuff we just took notes on, meaning the 5 assumptions, the conditions of an ideal gas, and the 5 properties. The remainder of the multiple choice questions come from understanding how the gas laws work. Okay? So I'm trying to illustrate how the gas law works here in my bad drawing. So Boyle's law is about volume and pressure at constant temperature. So if I have this container, and I'm just going to say that the volume is 1 liter, okay? And I drew a ugly thermometer. It looks a little more picklish than thermometer like. And I'm going to say the temperature is 25. Where? Yeah, it's supposed to be an arrow. Okay? And that's supposed to be a pressure gauge. All right? Yeah.
When's the first quiz?
On this?
Yeah.
We'll finish Tuesday-ish. We'll practice. We'll finish this. Best guess is Wednesday. Yeah. Yeah, I think it's Wednesday. Because we'll do, the first quiz will have 5 gas laws on it. So it'll probably be Wednesday. All right.
Are you just gonna ask us to make?
No, you got to work on 5. And the first quiz is all math.
You gotta draw.
The first quiz is on what?
The first quiz is all math.
Wait.
I
what?
don't
No.
Yeah.
Things why?
What do you mean, why?
Why?
You
Because
said
it
you
is,
like
Lolly.
this.
I told you, this is all for the multiple choice on the test.
Doesn't mean I can't fail it. You're gonna fall.
All right. So, we're going to take my container and shrink it, even though it doesn't look like I shrunk it. Let me see if I can shrink it. It doesn't look shrunk.
Oh, I thought you were showing these things.
No, they're supposed to look shrunk. Let me shrink it.
Exactly. Like, how would that happen?
All right, that looks shrunk. All right. Now, the question becomes, What happens to the pressure if I shrink the container?
You forgot to put the little
So we
pin
get
inside.
That's because I shrunk it.
Oh, I was supposed to.
Do we put the circle
You
on?
get tired and does that mean something different on the side now?
Well, it's supposed to be reading the pressure. It's supposed to be like a gauge. But, you know, my artistic ability is limited.
You have many paintings around the room.
Right, like there's another one.
They teach me how to do that in class.
Oh,
All right? I just don't hang out and
No
socialize.
excuse.
So what are those little paint drink classes where you?
Yeah, only I don't drink. I had hot chocolate.
It is supposed to be on the side.
I fell off the sidewalk, stone cold sober. You really think I need wine to go with it? I'd probably fall off the stool.
This was it.
I have been with the fall.
Is that supposed to be on the side?
It's supposed to be on top, but, you know, I already
It doesn't matter, I don't
It
think.
doesn't matter. It's just a gauge to read the pressure.
Okay.
Okay?
I didn't know what it was.
Essentially, the container is supposed to read temperature and pressure.
Okay.
Okay? You don't have to have it on there at all.
Okay.
I'm just trying to illustrate that our box has to read temperature and pressure. All right? Yeah, I gotta stick it up back there. I just haven't crawled up on top of something.
You got a lot of them.
These are just ones I've done, mainly because my son has tons at home and I have no place for artwork at the house.
That sounds kind of neat.
I like the beach.
That's the one we did for his birthday one year. The whole family went. All right.
Oh my God, you got them all. I like the pictures. I like how the
I don't think the art teacher thought she should pay them all.
I'm not paying.
Last night was Miss Cross, Miss Porter, Mr. Estrada. He didn't paint though. Myself. He couldn't stay the whole time.
So, do they make multiple calls?
Huh?
Do they make multiple points?
That's a cat.
Yeah, Miss Smith has.
That is a dog.
Yeah, Miss Smith was there.
Oh, we're talking about that one, like, that's a
No, I did
cat.
not hear.
I like that. So y'all made drinks.
Yeah, we
I
painted
did not have.
Why they look exactly the same?
I mean,
It's a paint.
It's a craft.
The peacock is the first one that we all did as a group.
I like the gold. So you did the fish?
Yeah, the fish I actually do with my son and daughter.
I like how the bubbles look. It looks cool. Fish is your. Is it
What's that one over there?
Right, is it like a Christmas tree sled?
It's supposed to be a Christmas tree. That one I did with a friend of mine.
I see it in North Carolina in somebody else's room.
I did with Miss Cross and Miss Porter.
How much does this house cost?
$35.
For what? For like a
For
class?
Yeah, for the class.
Can I have the next picture you take?
$35.
Yeah.
What all you get? Is it like one of those one and make things? I can't get that.
It's like,
I mean, so what you're saying is, you get to hang out with kids.
It's a social activity for adults for the most part.
So what you're saying is, you're gonna paint me a picture.
Can I
No,
have the next one you make?
Yeah.
No.
It's $35
If I give you
it is
$2.
How
$35.
often is this class?
These I've done over 2 years.
So like.
So I haven't done them all that often.
I like the dog.
Hey, Miss Paul.
I like the
If I give you
I like this one.
I think that's a good line.
I like this.
Now, moving on past my artwork. So, what creates pressure in the container? Yep.
Density.
Pressure?
Talking about, she said what?
Surface area.
Pressure.
Anti-surface area.
You gotta be able to tell me. What creates the pressure inside the container?
The size of the container.
The decrease.
Vacuum.
Think about it. What creates the pressure inside the container? This is important for all the gas laws, not just this one.
The leader.
Density.
Surface area, I don't know.
Just same answer.
Inside of any gas container, an aerosol can, a soda can, what creates the pressure?
Air, I don't know.
straw.
What do these particles do inside the container?
You don't drink air.
They bounce
The
around.
part-
They bounce around and do what?
They spin.
They bounce off each other.
Okay, so pressure is created when the particles hit each other And what else? What do they hit besides each other?
The wall.
The container walls.
Is that why we
We said the container.
I need you to be more specific. Okay, so pressure is created when the particles hit each other and the container walls. Does that make sense?
Mhm.
Now, we said temperature cannot go up. So are the particles going to move faster? No. All right. Temperature stays the same. So the particles do not move faster. Okay? They do not move faster. They're moving all at the same speed in this box and that box. It's got to do with pressure inside the container.
What is it? You clean like keyboards out and it's cold.
It's got to do with the pressure inside the can. You reduce the pressure in the can.
But how does the size of our box not matter?
That's where we're going next. Okay? So, what did we do to the size of the box? Okay. We decreased the volume. Now, if we decrease the volume, what did we do to the amount of space those particles have?
Decrease.
So, think about the main hall. Class change. There's less space for y'all to move around. So, what's going to happen to them? Are they going to hit more often or less often?
More.
So, what's going to happen to pressure?
Yeah.
They will collide, you said, more often. So if they collide more often, what happens to pressure? It increases. That's why I wanted you to tell me about pressure. Anytime they collide more often, pressure increases. Okay? So, notice what you said happened here. Volume did what? And pressure did what? So, what's the relationship?
Yes, volume decrease.
Directly proportional.
No.
Inverse.
Are both inversely?
They're just inversely.
Right, but there was another one. Yeah.
Oh, you're talking about pressure and surface area? Is that what you were saying when you meant they are both?
Yeah.
Okay. Everybody got it? All right, so how do we write Boyle's law? Pressure and volume are inversely proportional at constant temperature. Now, in parentheses, I'm going to write and moles. Because what I tell you about moles, are they changing?
No.
I told you, we're doing all of the moles in a few days. So are we doing anything in the moles?
No.
So are they changing? No. Moles are staying the same. We're not going to talk about moles. So if we're not going to talk about moles, are they going to change? No, they're not a factor. So all the gas laws we're going to talk about today, Tuesday, and Wednesday, well, at least until late after the quiz Wednesday, are the moles going to change? No. Okay, so what's the gas law that goes with this? What's the formula? P1, V1 equals P2, V2. Now, notice who's not in the formula. Did I mention surface area tensile wall?
Sorry.
There you go. There's no temperature because we said what in the gas law? It remains constant, so it's not in the gas law. Okay? You with me on that? Okay. So if the question says temperature is constant, or if it doesn't mention temperature at all, you're going to pick this formula. Okay? Are you with me on that?
Yeah.
Okay. Here's a sample.
Oh.
They're not short. There's no way to make them shorter. I would write one of each of them. I would not write two. I would write one. Do you have a sample to refer to? I will give you a moment to write it down. And then we're going to talk about how to solve. Now, the nice thing about the first really 4 gas laws is they all work the same way. Yeah, did I tell you have detention on Tuesday? It was just a stray thought that popped in my head. Okay, you have detention on Tuesday.
I'll be trying to do that.
And the reason it's Tuesday is we have a staff meeting on Monday, so they're not doing detention on Monday.
Well,
But you'll have
So
good
who all
company.
in there Tuesday?
I don't
I
know.
said it like it was a party.
Devontae and Lolly will be in there with you.
and Diamond.
And Diamond, and who else was late yesterday? Jada. So there's at least 5 of y'all from just first period. Y'all can hang out together.
Then like they can understand sign language under the table.
But you act like somebody finna
You know what? I don't even know if they're letting Monday detention people in there. They might have to bump them till Wednesday.
Oh, y'all should be deep.
Exactly.
That's not what.
Who invented this detention? Why don't they just do?
Yeah, who made all this shit? Who
Who
was that?
The discipline committee.
You old.
Who was that?
Magic.
A group of teachers who have 4th period plans.
Mr. Estrada,
I have 2nd period plans, so I'm not on that committee.
Mr. Estrada made it in. Without being able.
He's just the chair of the committee. He's not the only
Okay,
one.
that makes you
No,
worse.
So literally, what happens is you have repeat offenders. Doesn't they just think they repeat offenders? Well, I'm here
It sounds
a
like
lot.
you're a pedophile.
If you know me, I don't care.
Repeat offenders. And like you started like slashing people. What?
Yeah. They're not allowed.
Y'all don't know what's the animals that be in the kids on commercials?
I'm talking about hamsters. or
Yeah,
something?
that's what she look like.
Oh,
Who?
Stop.
Yeah, the teacher rules it, you know.
Kia, so they have.
It's a charity event. $2.
Right.
All right, well, let's check. Make sure you check your power score. Make sure you see it.
Bob works for $2. No, y'all know when she works for her. Bro, remember when Miss Sherry used to work with like a different wig every day?
Miss Cher was perverted. I don't care what
Oh,
nobody
Miss Cher
says.
was-
She was
I
perverted.
would've cried.
She used to make breathe. She's like, come here, breathe. She used to stand up and hold her hand up and make her turn around, look at us.
Man, she got married. I call her, hey, shit.
Like, she was perverted.
Right.
Follow Mister one time to be sick.
All right, do we have it?
Yeah, shit, your wig ain't smart.
She took her, bro, we was sick, so she came in there and took her wig off. I think she was trying to distract us. What we would have got a misunderstanding?
I know, right?
Like,
She
I
probably just
the
took
whole
it off.
question, but yeah.
She just wasn't
She
happy
just
with
took
that
her whole
bed.
wig.
Everything was bad.
I was so wrong.
Her office once.
Oh
She had
my
pictures
God.
of her. She had her, and I looked back and she didn't have.
And then there's a picture of her and her wife, but she like, I don't know what was going on.
I've never
They were
seen
like dressed up with all sorts of makeup.
So who wore the
drag? I don't know.
The wife is a whole.
Can we move on?
She's a girl.
No,
It doesn't matter. Now,
No, she's the girl.
when you look at the question, first of all, what gives it away is Boyle's law, because folks like Lolly, who are all bent out of shape about we're back in math, are gonna look at these questions on the quiz and be like, this law, I can't do it.
I mean, I've been not doing
I know it. So let's see if we can make it easier for you on the quiz. to say, okay, I can do this. So when you look at the question, what's going to give it away for you to say it's Boyle's law? All right, when you read the line that says temperature remains constant, right here. That's right. That's the only one that's going to say to you, this is P1, V1 equals P2, V2, because this formula doesn't have what in it? It doesn't have temperature in it, okay? Because the next one we're going to learn, for example, says V1 over T1 equals V2 over T2. So this formula has a temperature in it. Can you plug in to a temperature if it says temperature remains constant? No. Okay, that's the problem with it, okay? So you got to pick a formula that doesn't have temperature when it says temperature remains constant. Everybody with me on that? Okay. Now, here's why I've been so insistent on units all semester long. When you look at this, what is a milliliter? I have so failed y'all.
That's what I was saying. I'm not the only one.
Is it a volume, a temperature, or a pressure? Is it a volume, a temperature, or a pressure? That is so much better. All right. Is this a volume, a temperature, or a pressure? Thank you. Is this a volume, a temperature, or a pressure? Okay. What are they asking us to find? Find the question word. What volume is what they're asking us to find? Now, you don't have to write down as much as I write down on the board. I will tell you when you're working a quiz, more information you show. If you make a small error, of course, more partial credit I can provide for you. So, when I read the information, you can choose to set up the problem any way you wish. However, the information is provided to you in couples or pairs. When you read the question, you see how it says 150 milliliters when its pressure is 720? That's a couple or a pair. It shows possession. 150 milliliters when its pressure is 720. That 720 has to stay with that 150. So that 150 milliliters, if you make it the first volume, which I would because it's the first volume in the question, has to stay with the 720 mmHg. Now, as long as those two are together, they can just as easily be V2 and P2. But these two are a couple or a pair. They have to stay together. Now, what is the volume? Can be V2, and the 750 mmHg can be P2. Now, when you're done with that, the units must match. As long as these units match, you're good to go to plug in. If they don't match, you need to convert them both so they match. It doesn't matter what they are. They just have to be the same. So let's say that one's ATM and that one's mmHg. You just need to make them both match. They both have to be ATM or they both have to be mmHg. Does that make sense? At this point, for all practical purposes, the chemistry is done. You are at the step that I refer to as plug and chug. Plug in the numbers, chug out the answers. Okay? Molly doesn't like that. 720, 150 equals 750 times V2. All I did was put the numbers in that matched the letters. Now, I don't pick up a calculator at this point. Okay? And you won't see me pick up a calculator until I've solved for P2. What do I have to do to, V2. What do I have to do to solve for V2? Divide by what? So I'm dividing by 750. I'm dividing by 750. Now, when I grade your quiz, do I have any questions about what you did to get the answer? No. Now, do you have to do it that way? Absolutely not. But if I don't know how you went about getting the answer, I will tell you now, I'm not punching on my calculator to figure it out.
Wait, can you multiply first? And then rewrite it and then divide it by?
Sure, but I'm not, if you multiply wrong, I'm not going to figure out how you did it. All right, your units had to match. So your unit is milliliters because the units had to match. Now, well, homework. Let's see what I do. Yep. Anybody willing to hand out the second paper for me?
You got two papers.
You got 2 questions on the second paper.
Do we only do the,
Oh, go grab that paper on the corner of my desk.
do we only do the odd or even numbers?
So you're doing the odd on the first one and 2 questions on the second. So you got a total of 7 questions tonight.
This?
So,
Yes. All about this.
I wrote like a whole page.
I started first.
Which one did we roll the second?
All right, the one that I just handed you. You're doing 1 through 10, odd. All right, the one that Owen's handed out. You're doing 5 and 6. The one that I handed out, 1 through 10, odd. The one that Owen is handing out, you're doing 5 and 6. Okay? Everybody got it?
Yeah.
So that's 7 questions. I don't think that's going to kill anybody from the weekend.
This is a little.
You should be okay.
I could have a minor heart.
Try not to have a minor heart attack.
I don't think heart's minor.